Good morning, dear students, and welcome back to our online classes. Today we are going to start our new chapter number 6, Electrolysis. And in this chapter, according to your syllabus, we are going to start with electrolytes and non-electrolytes, the definitions and examples, substances containing molecules only, ions only, and both molecules as well as ions. And we'll also see definitions of electrolysis, electrolyte, electrode, anode, cathode, and later we are going to see anions, cations, oxidation and reduction. So with this brief introduction, we are going to start our chapter electrolysis. The word electrolysis is made up of two words, electro, which means flow of electrons or electricity, and lysis, meaning separating, that is, bringing about a chemical change in a substance by the passage of electricity. So the term electrolysis basically means bringing about a chemical change in any substance by passage of electricity. We all know that electricity is a form of energy. So this energy, when passed through certain substances, it breaks down that substances into other constituent substances. It breaks down the substance to produce new substances. That's why it is called chemical change. So this is a brief introduction. Now let us go in more detail. Now, according to the passage of electricity through any substance, we have two types of substances, and they are called conductors and insulators, or they are also called non-conductors. So non-conductors are also called insulators. Now, what are conductors? Conductors are metals, alloys, or any other substances which conduct electricity. Conduct means which allows electricity to pass through them. For example, copper, silver, iron, graphite. This pencil lead is made up of graphite, carbon, allotropic form of carbon. So graphite, being non-metal, it conducts electricity. Some compounds such as copper sulfate in its aqueous state, so always remember we have to write AQ. The solid state compound will not conduct electricity, although it is an ionic compound. It has to be in aqueous or molten state. Aqueous sodium chloride or molten lead bromide. This L stands for liquid or molten form. So molten lead bromide, they all are examples of conductors because they conduct electricity. Whereas insulators or non-conductors are those substances which do not allow electricity to pass through them, or in other words, they do not conduct electricity or electric current. Examples of insulators can be hydrogen, oxygen gas, methane, glucose, rubber, alcohol, urea, distilled water. Now, distilled water, it is the purest form of water. The water which we drink from tap is not pure water, it is mixture, and that tap water conducts electricity due to the presence of impurity in it, whereas distilled water, pure form of water, does not conduct any electricity. So now we know that there are two types of substances based on conductivity of electricity, and they are called conductors and insulators or non-conductors. Now in this chapter we are interested on conductors. Now let us see conductors then. Now conductors are also of two types, and they are metallic conductors and electrolytic conductors. Metallic conductors are those conductors which are made up of metals. For example, copper, silver, iron, okay, they are all metallic conductors. And These metallic conductors, they conduct electricity due to presence of free electrons. They have free electrons. Due to the presence of free electrons, they conduct electricity. And after the passage of electricity, after they conduct electric current, they do not undergo any change. For example, the electrical wires in our circuit, most of us use copper wire made up of copper. Once we turn on the switch of our electrical circuit, electric current gets carried from one place to another till the bulb glows. Now during that process, our wire does not change. If you are using copper wire, that copper wire does not change into silver wire or iron wire. The wire remains copper. Therefore, what metallic conductors have their property? They do not undergo any change, and they conduct electricity due to the presence of free electrons. Whereas if we see this electrolytic conductors, examples of electrolytic conductors can be aqueous copper sulfate, aqueous sodium chloride, molten lead bromide, or acidified water. In water, if we add acid, then it is called acidified water. These substances are called electrolytic conductors, and they conduct electricity due to the presence of free movable ions. Here they have free movable ions. Now metallic conductors, they conduct electricity due to presence of free electrons, whereas electrolytic conductors conduct electricity due to the presence of free movable ions. And this electrolytic conductors, after the passage of electricity, they undergo chemical change. Like copper sulfate will not remain copper sulfate once electric current is passed through it. It will produce metallic copper and sulfate ion. Okay, so they undergo these electrolytic conductors, they undergo chemical change, whereas metallic conductors, they do not undergo chemical change. So these are the differences, and the differences between metallic and non-metallic or electrolytic conductors are given in your textbook. You can refer to this table for detailed differences between them, okay, which I am not going to discuss. I have given you two basic differences between them. Okay, we'll stick to these two differences in our video. I suggest you to refer to your book in more detail. Now we are more interested in this chapter on electrolytic conductors, okay, because our chapter is based on electrolysis, which uses electrolytic conductors. Now these electrolytic conductors are also called electrolytes. And electrolytes are those compounds which either in aqueous solution or in molten state allow electric current to pass through them. So any substance which either in their aqueous state or in their molten state allows electric current to pass through them, then they are called electrolytes or electrolytic conductors. Electrolytes can be acids like sulfuric acid, nitric acid, phosphoric acid, hydrochloric acid, but they all are good electrolyte only in the aqueous state. Okay boys, now bases can also be electrolytes like sodium hydroxide, potassium hydroxide, ammonium hydroxide, calcium hydroxide. They all can also be electrolytes, again in their aqueous state. Salts are also examples of electrolytes. Salts such as sodium chloride, copper sulfate, lead bromide, and there are various other salts which are Examples of electrolytes. Again, they have to be in their aqueous state or in their molten state. Now, these are some of the examples of electrolytes. Now, there are some substances which do not conduct electricity. And those substances or compounds which either in their aqueous state or in molten state do not allow electric current to pass through them are called non-electrolytes. So non-electrolytes are those compounds which either in their aqueous solution or in molten state do not allow electric current to pass through them. Examples can be alcohol, urea, distilled water. They are all non-electrolytes. And these non-electrolytes, they all contain molecules only, neutral molecules. And neutral substances do not conduct electricity. Only those which have charged particles or free movable ions or electrons, they conduct electricity. So non-electrolytes, since they do not conduct electricity. Why they do not conduct electricity? Because they have only molecules. They don't have ions, free ions or free electrons. Is that clear, boys? Now let us see types of electrolytes. Now there are two types of electrolytes, and they are strong electrolytes and weak electrolytes. Now what are strong electrolytes and what are weak electrolytes? Let us try to understand these two terms. Now strong electrolytes are those electrolytes or those compounds which dissociate almost completely in aqueous or molten state. They break down or they separate into their ions completely in their aqueous or molten state. Therefore, in their aqueous state or molten state, they contain ions only. So strong electrolytes are those electrolytes which contains ions only in their aqueous or molten state. For example, hydrochloric acid, aqueous hydrochloric acid, but they all have to be in their aqueous or either in molten state. So aqueous sulfuric acid, aqueous nitric acid, aqueous copper sulfate, this is a salt and these are acids. Aqueous sodium chloride, molten lead bromide. These are all examples, some of the examples of strong electrolytes. And why they are strong electrolytes? Because they all contain, they dissociate completely and therefore they contain ions only in their aqueous or molten state. Thereby they conduct large amount of electricity through them. Whereas weak electrolytes are those electrolytes which dissociate partially in aqueous or molten state. Since all the molecules do not separate into their ions, therefore their solution contains both molecules and ions. So a weak electrolyte has both molecules and ions. For example, acetic acid, carbonic acid, oxalic acid, aqueous ammonium hydroxide. This is a weak alkali. Okay, and these are all organic acids except carbonic acid. This is a weak inorganic acid, and these two are organic acids. And we all know that organic acids are weak acids. We have learned that in our acid, base, and salt chapter. Ammonium carbonate is also a weak this salt, okay, and this is also a weak electrolyte. So what we have to know between strong electrolyte and weak electrolyte, that strong electrolyte dissociates completely, almost completely, and therefore contains ions only in the aqueous or molten state and conducts large amount of electricity. Whereas weak electrolytes, they dissociate partially in aqueous or molten state and therefore they contain both molecules and ions and they conduct less electricity. Is that clear, boys? The differences between strong electrolyte and weak electrolyte are given in detail in your book in this table. So you can refer to this difference chart in your book. Now, since we are discussing about electrolytes, so these electrolytes are special compounds, okay, and these are used to carry some chemical process, and that chemical process which these electrolytes are used is called electrolysis. So let us see now what do we mean by electrolysis. Now, electrolysis, let's go to the definition first. Electrolysis, it is the process of decomposition of a chemical compound in aqueous solution or in molten state, accompanied by a chemical change by using direct electric current. So you have to remember the process of decomposition of a chemical compound in aqueous solution or in molten state by the passage of which brings about chemical change by electric current. So a chemical change, or in other words you can say a chemical change brought about by the passage of electric current, which results in the decomposition of a chemical compound, is known as electrolysis. And this electrolysis is carried out by using electrolytes, which we have discussed right now. This electrolysis can be carried out by using two different instruments, or we call cell, and they are electrolytic cell, which is also called a voltmeter, okay, and another one is electrochemical cell. Now in electrolytic cell we use electrolyte, we also use electrodes. Later on we'll learn what are electrodes. We use electrolyte, we use electrodes, we use this vessel. The vessel in which electrolysis is carried out is known as electrolytic cell or voltmeter, and these two electrodes are connected to an external source of electric current, okay. This can be a battery also. This can be supplied from our main electric source, main line, which we have at our home, which we use at our home, okay. Now in this process, electrolytic cell, we have to supply electric energy from external source. That electric current from external source enters the electrolytic cell and through the electrode and dissociates the electrolyte which is used over here, okay, and this electrolyte now carries electric current from this electrode to this electrode, and thereby they form a closed circuit, okay. So electrolyte acts as one circuit, type of circuit, closed circuit, okay. This is called electrolytic cell. In electrolytic cell, electric current is brought from external source to carry out the process of electrolysis. Whereas in electrochemical cell, we don't need to supply external electric current. The electrolytes undergo chemical change, and when they undergo chemical change, electric current, they generate electric current. Here electric current is not generated. Already generated electric current is passed into the electrolytes. Whereas in electrochemical cell, due to chemical reaction taking place in electrolytes, electric energy gets produced, and that electric energy is used by other external sources, okay boys. So here electric energy is taken in, and in this process electric energy is given out, produced. Examples of electrochemical cell can be our simple batteries which we use at home, or the batteries which are used to run our cars. We don't plug our external circuit to our car battery. The battery produces electric current due to chemical reaction taking place in the electrolyte. Am I clear, boys? Now these two rods which are dipped in the electrolyte, they are called electrodes. So let us see what are electrodes now then. So electrodes are metal plates or wires, or graphite rods or gas carbon rods. These are all different types of electrodes immersed in the electrolyte through which the current enters and leaves the electrolytic cell. So from here electric current enters from the negative terminal. Electric current enters into the electrolyte, and from the positive terminal it leaves the electrolyte and reaches the external source battery. Always remember, electric current enters from the negative terminal and exits the electrolyte from the positive terminal. Negative terminal is denoted by drawing small short line, whereas positive terminal is denoted by drawing long straight line. Am I clear, boys? So electrodes are metal plates or wires or graphite rods or even gas carbon rods immersed in electrolyte through which electricity enters and leaves the electrolyte cell. Now there are two types of electrodes, and they are anode and cathode. Anode is the electrode which is connected to positive terminal, therefore this is positive in nature, whereas cathode is the electrode which is connected to negative terminal, and therefore its charge is negative. So there are two types of electrodes, anode and cathode. Anode is the positive terminal, whereas cathode is the negative terminal. So I hope I have made you clear up to here, boys. Our video is becoming very long, so I think it's time to end our today's video. Please refer to your book for more detailed study, and you can always mail me or WhatsApp me if you have any difficulty in understanding today's lesson. Till then, stay safe and do all things well.